In this tutorial I will talk about an all-in-one solution to create the movement for dashing, dodging and sliding. There are many tutorials about this topic that use the launch character node to achieve this, but I found this method very inconsistent and prone to bugs. Another popular method is to use root motion, but this depends on your animations coming with proper root motion setup, and it's hard to influence the movement distance within Unreal Engine itself. My favorite method works by directly influencing the velocity of the character movement component, doesn't rely on root motion animations, also works with sprite-based characters, and the movement distance can easily be changed depending on the stats of your character. So let's get started. I simply created a new project from the third-person character template to get a character that already has the basic movement setup. But they don't come with a dash, dodge or slide animation. Sadly, I can't provide you with an animation file, and you'll need to get an animation pack from the marketplace that fits your character if you haven't already done so. I will use animations from the frank/pack I already have in my library. In my case, the animations are made for the UE4 mannequin, so I'll quickly retarget them to the Unreal Engine 5 character. You'll then want to create an animation montage from your animation assets by right-clicking on them, selecting Create, and create Anim Montage. I'll prepare an animation montage for dash stepping and one for the evasive roll. When using animation montages, you need to look into your animation blueprint and make sure that a slot of default slot is set up in your animation graph. Otherwise, they won't be played back even if you trigger them from your blueprint. In the character blueprint, I will delete the jump functionality and reuse the input for my dodge functionality. First, we just need to create the play montage node. Here we need to make sure not to forget to drag our character mesh into the in-skeletal mesh component pin. For the montage to play, I'll select the evade roll first. When we now go into the game and press space, you can see that the character is correctly playing the animation montage, but we don't have any movement yet. To create movement, we will first add a timeline. Double click on it to open it up and set the length to around 2 seconds, and don't create a track just yet. At first we will simply use a static value each time the update is fired off, instead of using a curve. To get reliable movement, we then just want to grab a reference to the character movement controller and call setVelocity on it. In Unreal Engine you rarely set velocity directly like this, because we have so many helper functions like launch character or add impulse that there's rarely a need for it. But in this case it's exactly what we are looking for. Actually, in other game engines this is a very common thing to do, and there's nothing weird about it. Since we want to move in the direction our character is facing, we get actor forward vector and then multiply that by a float. In my case, I create a variable called move distance and set it to 500. This will give us a scaled directional vector and create movement on each update when we plug that into setVelocity. You can see that the character is moving now, but we are still sliding after the animation is done. This is because the timeline is longer than the animation. We can open up the animation montage or animation of the evade roll and check the length of it. In this case it's 0.58 seconds long. Open up the timeline and also set the length to 0.58. Now it's looking a lot better, but we are still sliding a little bit after the animation. This happens because near the end of the animation, when the roll ends, we aren't actually supposed to move anymore, and also due to animation blending. So we want to add a curve to the timeline to fix that. In the timeline, add a float track and call it distance multiplier. We can then right click to add a keyframe. The first one should be set to a time of 0 and also value of 0. Another keyframe should be near the end when we want our movement to stop and also have a value of 0. In between we can then add 2 more keyframes with values close to 1 to create a lot of movement. With this setup, our roll will quickly build up, create a lot of movement and then slow down and come to a stop. We can then use this distance multiplier and multiply it by the move distance. This is already looking pretty good. You can still make additional adjustments to the curve until you're happy with the result. One of the big benefits of using this method is that we can easily change the movement distance by only changing the value of this one variable. I will simply set it from 500 to 1000 to demonstrate this. But in your game you could have this value affected by your character's agility, for example, and gradually raise the number. You can see that we cover a lot more distance with our dodge roll now. You can also see that we get very natural interactions with the walls and objects in the stage. But there is one issue. When we roll over a ledge or use the roll mid-air, you can see that we don't fall down naturally, but rather keep a fixed height until the animation is over. There are some cases where you might actually want this, like for example Wario's shoulder tackle in the old Game Boy games. In that case, you could also add a note to set the movement to flying before starting the timeline, and then set it back to walking after the timeline has finished playing. But in most cases you would want to descend naturally, so let's get rid of this again. So why do we not descend naturally? This happens because in set velocity we actually override the velocity that gravity wants to apply to the character. For our movement we only need to set the x and y velocity, so let's split the struct pin and only plug those two in. We can then get another reference to the character movement component and call getVelocity on it. Here we only use the velocity z and plug it into velocity z of the setVelocity node. This will now basically just set the z value to what it already is, so we don't change it by ourselves and let gravity take care of it. Now you can see that our evasion roll behaves correctly even if we go over ledges and always has the same fixed distance. The dodge roll is working now, so to demonstrate how dynamic the system is, let's now apply it to the dash step. Simply select the dash step montage as the montage to play, then check the length of it and set that as the length of the timeline. Rearrange the keyframes to fit the new length and animation. With only these few changes, we now have a completely different animation that reuses the same movement logic. If we keep on hammering the space button though, we can still cancel the animation and restart it from the beginning. There's a really easy fix for this. We need to create a boolean variable. I'll call it isMovementLocked. Before executing the dash, we then need to create a branch and make sure to only execute when it's not locked. After that we set it to locked. When the animation is completed, we unlock it again. Now even if we mash space, the animation needs to play out first. But when we use our movement buttons we can still interfere with the dash. So we add the same branching logic to the movement inputs and only allow execution when movement is not locked by the dash. Now it's working perfectly. I actually discovered this method of dashing or sliding movement through applying velocity when working on my sprite-based 2D beat-em-up. So you can see this method is super flexible and doesn't even rely on a mesh or animations at all. So hopefully you now know how to implement the system for your dash, dodge or slide movement. To give you an even deeper understanding of the topic, I'll quickly talk about the other two common methods as well and why I chose to teach you the velocity method. The method you'll come across in most tutorials is the one using the launch character node. First, I'll add the launch character node. Again, we need to get the forward vector of the character and then add a distance multiplier to it. When we start the game now, it doesn't really look too bad and seems to work similar to our setVelocity method, but the real issue happens once we go over a ledge. While we are grounded, our character is fighting against ground friction, so we need to set a high value for the movement distance. But when we are airborne there is no friction, so we are launched off with much more force and cover way more distance. In some cases you might actually want this type of behavior, and we actually ended up using this bug as a feature in one of our games. But it's very hard to control, and most of the time you'd be better off using the setVelocity method to have a more controlled and reliable movement. Another popular method is using root motion, and you can create amazing results with it. Root motion is movement of a character that is based on the animation of the root bone in the skeleton. But if you buy assets from the marketplace, you are sometimes out of luck and they don't come with root motion built in. Assuming you have an asset that does use root motion, you can see movement like this in your animation asset. In this case we only need to play the montage and don't do anything else to achieve movement. We also have physics applied naturally and don't have any issues when going off ledges. But a problem with root motion is that the animator is the person deciding what distance the roll covers, instead of the game designer or programmer. The distance might not match your game, so you'll need to make some adjustments to it inside of Unreal Engine. We can go into the animation and add some keyframes to create a curve and make the movement either longer or shorter. However, this still means we need to create different assets for different distances and can't just have the length be affected by something like our character's agility, for example, which is why I prefer the set velocity method. Now that you're an expert on dodge roll movement, how about mastering hit stop to create an even better game feel for your action games? Click here to check out my tutorial.